Cream is great. We use it to make delicious treats like ice cream and to turn bitter black coffee into a smooth and tasty beverage. But this seemingly pure ingredient normally has other chemicals added to it. Check the nutrition label on a carton of cream and you might find all sorts of ingredients. Polysorbate 80. This sounds like something unwholesome and scary. What is it doing in cream? If you have a background in chemistry, you might have guessed from its name that this chemical is a polymer, since its name begins with poly. You are probably right next to some other polymers right now. I looked around my office and found these examples. The fabric of my backpack is the polymer nylon, and so are the buckles. This bottle is made of high-density polyethylene, just like a milk jug, and it is recyclable. This other bottle is made of PET, like most recyclable plastic drink bottles. This swimming gear is made out of polymers like spandex and silicone rubber. My water bottle is made of polypropylene. Let's take a closer look at this water bottle. My water bottle is made of polypropylene, which contains only carbon and hydrogen atoms. Chemists often take a shortcut and skip writing the C and H atoms so that it looks like this. This polymer has 0 oxygen atoms, which means it is chemically different from water and will not mix with water. This is actually a good thing. It means my water bottle can contain water without being broken down by the water. Polysorbate 80 is different from the polymers used to make plastics because it has almost as many oxygen atoms as carbon atoms. The oxygen atoms make polysorbate more like water, since water also contains oxygen. Since they are similar, they will mix with each other, and polysorbate will dissolve in water, unlike most other polymers. The number 80 tells us that polysorbate 80 has 80 copies of the piece shown in brackets. Only 4 copies fit on this screen, so the molecule must be pretty large. Most polymers are shaped like a long noodle, but polysorbate 80 is shaped more like a hand. It has 4 fingers that have a lot of oxygen and are represented here by blue paper. These parts allow it to mix with water, since they are similar to water. It also has a piece without oxygen that is represented by orange paper. This piece of polysorbate 80 is more like fats, so it mixes well with them. This is the chemical structure for polysorbate 80. The brackets, here, 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 and here, tell us that those parts of the molecule have a repetitive structure. This portion in brackets is repeated for a total of 80 times. The fingers can be different lengths. This one might be really long and these might be short, but there has to be a total of 80 repeats. Cream is mostly water, but is about 35% fat. Fat and water do not mix well with each other, so cream that is sitting for a while will begin to separate. The fat will start to stick together and separate from the rest of the cream. When polysorbate 80 is added to cream, it surrounds the tiny fat blobs. One part of the polysorbate mixes with the fat, and the other mixes with the water. Since polysorbate has parts that are similar to both kinds of chemicals, it can force them to stay mixed with each other, so that the cream stays fresh longer. Thanks, polysorbate 80!